Hello everyone. Today we will be looking into the DataProc service that is provided by GCP. So DataProc is a managed Hadoop service, as we have discussed about it in the earlier sessions. So today we are going to create a Hadoop cluster using a DataProc service, and we will try to use that cluster and run some HDFS commands as well as Hive as well as Spark. So first of all, since it is a managed service, so we have an option of choosing the cluster of our own size, which basically means if I need to process a job for of say 100 GB in size, if my data is around 100 GB in size, then we can select the cluster appropriately. This helps because if you are going to create a very huge cluster, then it will incur a lot of charges. Also, if you create a smaller cluster, then your job will not be successful. So, to keeping that in mind, we keep a cluster. We want to create a cluster of on optimum size. Now, there are two ways. One is either you can have a cluster and it will keep on running always. Let's say if you want to use Hadoop as a whole in GCP, which means that you want to use all the services of Hadoop, be it Hive, be it Spark, be it HBase, all of the services. You just want to, there is an on-premise Hadoop cluster. Now you want to migrate it to GCP. All things as is, like still you want to store your data in HDFS and everything will be like, and this cluster will keep on running. It won't ever stop. So that is one scenario. And the other scenario is that you want to move away from uh, Hadoop in a way that you just want to use your Spark jobs that should be executed here in the DataProc, but I don't want to keep the whole cluster as a Hadoop cluster. We want to leverage other services, like I want to store my data in GCS, like a Google Cloud storage instead of a SDFS. I want to store my NoSQL data in uh, big table instead of a HBase, or I want to store have a data warehouse in BigQuery instead of a Hive. So that is the other scenario. When you are going completely PaaS, platform as a service, then you would be needing DataProc only to execute your jobs, or you just want to have a cluster running for a shorter interval of time. So you will be charged only for the resources that you are going to use. Other way around is you want to have a ever running cluster, which will look similar to what you had in your on-premises setup. It will be similar, but it is just on GCP, which means that you don't have to manage the server. Everything will be done by GCP. You have to just create a cluster and move your jobs to you move your data to this DataProc cluster. So let us create a demo cluster now. Let's say I want to use SDFS and like complete Hadoop ecosystem that we had in on-premise. I want to use all those things in the DataProc. Okay. So we first give the cluster name. These are the bare minimum requirements that we are going to fill. And it will ask for the region. Let's select some region in Asia. Let me select Asia Southeast one, let's say. Region if you want to select where in Asia Southeast one you want to have your cluster setup, then you can select anyone or you can give any and it will be creating any one of them. Now, there are three different options provided for for the setup. Standard is one master node and n worker nodes. N workers maybe 2, 3, 5, 10 as per your requirement. One master means there is only one master. This particular cluster is basically a standard cluster, but in the sense that if one master fails, then there would be issue in this cluster. Then there is a single node cluster where we only have a master. So this is mostly for, if you want to do some POC and you just want to see how HDFS works and everything, then you can select this one. Like it won't be giving you workers and hence, you will be saving some cost. Third one is the high availability cluster, which has three masters. This means that if even if one master fails, then we have other two to catch up. So this makes sure that there's minimum or no downtime in your HDFS or in your Hadoop setup. We'll go with the one standard cluster just to show you like how we can set up n workers. One master is similar to, we can have number of masters three. So, but the thing is, if you want to have more or less workers, the n workers, so n can be one, two, three, four, based on our requirement. No need to change here. This would be the latest image of of Linux system. So they are using Debian. Let's keep it as is. You can have other options as well. Like if I go to this, they'll give you multiple options. Let's say I want to use, instead of using Debian, I want to use Ubuntu. Then you can click on Ubuntu. And I want to keep my Spark version 3. And here you see we have Spark 3.3, Spark 3.1, and Spark 2.4. If you want to have a custom image, you have your own image that you want to use, you can very well go here and select that image. In our case, we are going to keep it default. Okay, default as in latest one, Debian 11, Hadoop 3, and Spark 3. Auto scaling policy, we can select the auto scaling policy as well. Let's say if I want to, if my job is asking for additional resources, whenever there is a high load on the cluster, we can create some auto scaling policies. We are not going to do it for now, but you have this option available. So you first have to create the policy, and then you just have to come here and select. So you can create the policy in the other service. Network configuration, if you want to use the VPC, virtual private cloud, that is created by that is created by us, like a DevOps or admin team, that you want to use this particular VPC. What it will do, it will VPC basically is the setup which will create a security group and all those networks which won't be accessible by the internet, or it is not publicly accessible. So there are multiple rules that a company or anyone who is creating a project uh, set up, so that there is no unwanted access given to anyone. So we are going to not create this VPC. We are going to use the networks in this project. Basically means when this cluster will get created, all the things will be established here only. But if you want to have some additional rules set up, then you should have a custom VPC. Okay. Selected project where you want. I want to create this in my first project only, so we'll keep it as is. Metastore service. Metastore service is a chargeable service. It will keep your metadata in a when a cluster shuts down, it will persist your metadata, tables metadata. Let's say if you have a Hive metastore, then all the information about Hive table will be stored in this metastore service. It is pretty much costly. So, but yeah, when you are going to create a production grade cluster, you you should enable this metastore service, so that if a cluster there's some downtime or outage, or due to some reason your cluster fails and it is not able to be revived, you will have your metastore which will persist all the tables metadata. Now if you want to have some additional component, let's say I want to use Hoodie, or I want to use, let's say I want to use Solar, or I want to use Jupyter Notebook for PySpark. All those things will be available here. You just have to select those additional services. Okay. In the configure node, you just don't go and create, it will create a default cluster. You first go to the node options and you select the node of your choice. Let's say if your job is highly compute intensive, then you can use the compute or optimized kind of resources where you will get more CPUs. If you see, there are multiple C2 type of instance, which is compute optimized, and you can select from any one of them. Then there's the memory optimized when you need more memory. This is true when you are going to use do a machine learning job is going to run. So it requires a lot of memory in a single node. means each node should have a lot of memory, then memory optimized kind of a workload of a cluster we can choose. If you want to run your deep learning, which requires neural networks, which requires GPU usage, then you can select from here that I want, okay, I want a GPU resources. So let's go here and select it. For our case, since we are, we are learning Hadoop, we just want to have a bare minimum so that we can save on cost. So we will go and create a simple cluster with two virtual cores and 8 GB memory. Okay, so let me create this. Now, there are other options as well, like how much primary disk size you want, how many number of local SSD, and which type of a disk you want, SSD kind of or a standard persistent hard disk kind. So it will give you multiple options that you want to choose. Now, this was the master node setup where you wanted a two CPU, two vCPU, one core memory. In this case, for the worker also, we are going to do the same setup. We are going to say that, okay, I want the standard, like a standard cheapest cluster or cheapest compute resource. So it will give you 8 GB. And now here you can set how many worker nodes you want. For our case, to see how distributed setup is done, we are going to stick with two worker nodes, but you can increase this as well. Similar to that, you can also set up the disk size here, like how much storage you want in your in these worker nodes. Then, if you want to have more security options, you can have shielded VMs. And yeah, so these are the bare minimum requirement. If you want to make more changes, like when do you want to delete this cluster, I will say that after 10 minutes of idle time, minimum is 10 minutes, just delete this cluster. Okay. If you want to store all your metadata logs in some GCS bucket, you can provide the name. Otherwise, it will create its own bucket, a default bucket, and yeah, it will create. Similar to that, if you want more, control, you can create a customer managed key encryption. Just this Google managed key is also, more insufficient. But if you want to have a customer managed key, you can use the key management service. After all of this, you just click on create a cluster. Okay, so what it says that if since we had selected HBase, it requires Zookeeper as well. So let's go here, and since we are not going to anyways use HBase and save some cost, we'll just go and deselect this option. Now, once you click on the create cluster, it will take some time to create. Once this cluster is created, we can leverage this cluster and run a resource. So if you see, there was a test cluster that I created earlier, but since it was set up that if there is a 10 minute of inactivity, delete that cluster. So it got deleted. The auto scaling policy that we're discussing about, it is here. You can go here and create your own auto scaling policies, and then you can use this policy. So if I want to create a auto scaling policy, it gives you a lot of options. Like for map reduce, how do you want to scale? In with Spark, how do you want to scale? Similar to that, if you want to have some dynamic allocation, then what is the how much you want to scale? All those options will be available. Then scale up is factor, scale down factor. And how do you want to, once your work is done, how do you want to decommission it? Basically meaning that let's say I am running a job and which requires auto scaling, and it will take around 1 hour or 30 minutes. So we have to make sure that we are going to have a graceful decommissioning. Otherwise, what will happen? Your job is still running, and this decommissioning will start, and it will impact your job. So once you do all of this thing, you can click on submit, and auto scaling policy will be created. Okay. Let's see, in a couple of minutes it should get started. Meanwhile, let us look at other options as well in this cluster apart from this. So Metastore service, this is the Metastore service I was talking about. This Metastore service is going to be used when, if you want to create a cluster and you have to have a Metastore service. So whenever there is a, there is a outage, it will make sure that all your metadata is in place. Okay. Then there are other utilities. Let me open this. Then there are other serverless options as well. So as I mentioned that there are cases when you don't want to keep your cluster running. You just want to run your Spark job and shut down the cluster. In those cases, there's a serverless option available. You can have there's a batches. You can go here and create your Spark job. You will say create, and it will ask for a few options like what type of container you want. If you want a Spark Scala kind of a container, you can use this. If you want a PySpark, you can choose PySpark. It will ask for a runtime version. You can select any one of it. Like, I want to use Spark to 3.3 and Scala 3.3. Here you have to give the location, GCS location of, of your code, which you want to execute in this particular job, PySpark code. Additional Python files, custom images, additional jar files that you want, all the options are available. So whatever the options Spark provides, all of them are available here. Then we have discussed about PySpark, where we can, we can set executor and driver configurations. How many drivers you want, how many executors you want, all of those things you can, set up over here. Similar to what we were seeing in the while creating the Hadoop cluster. If you want to use your own VPC, you can select this option and you can select a subnet. We are currently going to use the network VPC in this project, so we are not going to make changes. Metastore service like this, what we saw. And yeah, so this is all that is required. Once you give the file name and all those things, you can just create, submit, and your job will start. Also, you don't have to, manually come here and create your job. This can be triggered with the help of a REST API as well. So if you see, if I have a REST API, I can give all the options and it will submit a job and create the cluster of first choice. So you don't have to come here and manually do. In production, RS job actually gets triggered and this Spark plus Spark jobs get submits and get executed in DataProc. I think our cluster is also ready. So yeah, so this was an option. If you want to run interactive serverless, you can create an interactive session as well. Okay. Then there is a concept of a workflow in DataProc. If you want to, create a workflow out of your jobs, you can do that as well. So these options are available. Now let us go through the topic of the day, how to create a HDFS cluster and run your code inside it. So we have seen how to create a cluster. Now see, if you see, the cluster is in the running state. So let me go inside this cluster. You can either submit a job like a Spark job directly. You can click on submit. It will ask which type of job it is. Is it a MapReduce job or a PySpark job or a Hive job or a Pig job? All of them. It will ask all the details like I have shown you just a few minutes back. So all the details you can provide and you can submit the job. But if you want to, go and see how run some commands inside HDFS and see the data, all those things can be, is available over here. So you have to go to the master node. So if you see, we have one master and two worker like we wanted to set up. You can go to this master. It will bring you to the compute engine. So since we are using the compute engine kind of instance, hence it is a compute engine. Now, if you want to log in to this node, you can do a SSH. Once you do a SSH, it will create, it will open a VM, and you can, see your Hadoop cluster running inside. So you can connect to HDFS, you can connect to Hive, PySpark, all of those things you can very easily connect here. So it will ask for authorize. You can say yes. It will authorize with a Google account. And yeah, here we are. So this is the HDFS cluster. It is the not it is the worker node where HDFS is getting. Sorry, this is a master node. Master node basically connects to all the workers. So generally we log into the master node, which will have all the clients that are required by our in production. So say if I want to connect to Spark, it will have a Spark client. If I want to connect to Hive, SDFS, all of them we have. So let's say I want to see what all files are available or what all directory are available. Like we have mentioned that with their commands like SDFS, we talked in the earlier recording that there are multiple commands. Like if I want to list the directories, I can do SDFS DFS hyphen ls. So let me see what all directories are available. So SDFS, so DFS hyphen ls shows me that there are three directories. We'll go inside user. Okay. So let me see. Inside user, we have so all the services will have all their data metadata stored in respective directory. HBase will have its data available in user HBase. Similar to that, we have a user called DataProc. We are going to use this user for our case. So if you see SDFS ls, SDFS DFS hyphen ls, and you give the directory name, you can see what all content is available. Now, if you see there is nothing available in this DataProc. So first, let us create a subdirectory inside this. So the command was sdfs dfs hyphen mkdir. So let me create a temporary directory mkdir slash temp. So hyphen mkdir is the command that we use in SDFS. It got created, and let me see if the directory is available or not. Yeah, we can see a temp directory available. Now to remove directory, we are going to use sdfs dfs hyphen rmdir. So I'll come here and I'll do a rmdir like this. So this should remove a temp directory. Okay. So if you see here, now I won't be having the temp directory available. Yeah, we don't have. Now, if I want to copy the data from local machine or to SDFS, let's say this is a master node. In the master node, if I do ls-ltr, I don't see any files. Let me create one file. Let's say touch test.txt, and I want to move this file to SDFS. So how do we move this? I'll say SDFS DFS hyphen copy from local, and I'll say that copy it inside user DataProc. You also have to mention the file name, which is test.txt. Once this command get executed, we should have the data available in SDFS in the DataProc folder. So let me see SDFS DFS hyphen ls users list DataProc. Yep, we have the file. Now, if I want to get this file into the local machine from SDFS, we can use the copy to local command. So let me create some directory mkdir data. Now we have a directory called mkdir, called data. Let me copy this file test.txt to this location. Okay. So I'll say SDFS DFS copy to local. I'm sorry, SDFS DFS copy to local. What file I want to copy? I want to copy a test.txt file, and I want to copy it in the data slash. This command should copy the data, this test.txt file from HDFS to the data location. So if I do a ls data, it will show me the test.txt. So if you see, we are in the home/data engineering in the this Linux machine, and it is not, and this folder is in the this Linux machine, but not in the HDFS cluster. So whenever we run this copy to local command, it will connect to the HDFS cluster and look for this file and copy this file to data folder, which is in the local setup, not in the HDFS setup. So whenever we do a HDFS DFS, this master node, since it has the client installed, it will connect to HDFS. So this particular file, these files are inside the HDFS, and we are using these files whenever we want to copy to local, we are going to copy it. But if I want to run my PySpark job, it should know that, okay, this is the HDFS location and I want to read the file from here, because Spark won't be able to read the file from the local because it don't understand this part, but it understands the HDFS part. Okay. So we have seen how to copy from local and copy to local. Now let's delete this file from HDFS. So there is a command called as rm hdfs dfs -rm. You have to give the path. Okay, so there was some issue. Let me reconnect to this instance. It sometimes happens whenever there is a network glitch, this SSH browser will, behave unexpectedly. So let me restart this. It will take, I guess, some time. Or let me create another SSH instance. Let me click on a new SSH instance. Okay, there's some issue going on. Got it. So looks like since we had set up this inactivity period to 10 minutes, the cluster got destroyed. Let me create a new cluster with the same configuration and I'll resume this video again. Okay, so I have created a new cluster with 2 hours of fixed scheduled deletion time if there is a 2 hours of inactivity. So how does this data prognosis that there is an inactivity? It looks for any job running in. So if we are using the SSH instance, it doesn't mean that you are active. If there is any Spark job or or a Hive job or any job is executing, then only it understands that, okay, there is some job running and you should not delete the cluster. So let me so we have discussed about the commands like HDFS put copy from local, and if you want to do the HDFS, like if you want to delete some file, let me create the file again and put it here. This is a file. I'll just do HDFS DFS -copy from local test.txt to user/data-proc. Then this will copy this file to this location in the data-proc folder. So when I want to see, I can see HDFS DFS -ls user/data-proc, and it will show us the file that we copied. Now, if I want to remove this file test.txt, then what I'll do, I'll just do a rm. I think it should work. Yep, it says that it has deleted the file. Now, so this was the simple HDFS commands that we have just used. Now let me create some file. Let me create a folder called let me create a file called cust.csv. and let me write some records here. Let's say ID is 1, name is John Snow, and age is 28. Similarly, ID is 2, then name is Alice Perry, and age is say 30. And then say there is one more record, like say Glenn Maxwell, and age is 35. Now I have created a file cus.csv. I'm going to create a folder inside HDFS, HDFS DFS hyphen mkdir and slash user slash data proc slash data. I'm going to create this data folder, which inside which we'll keep all the data that we have. So whenever we create a data lake is nothing but all kind of data present in HDFS when we are talking about on-premise, and you will keep all your data inside a data folder, inside the folder. But yeah, you want to have a single point to access multiple records. So inside this, I'll create a folder called customer. Okay. Uh, so this is the customer folder inside which we will be having the cust file. All the data related to customer will go in the customer folder inside HDFS. So I'll say copy from local cus.csv to customer. Now, if I do HDFS DFS hyphen ls and look into this, I should be seeing this one cus.csv inside. And if I want to see the content, this is the content that we have. Okay. Now, so there is an issue with this file. Let me first remove this. I'll tell you what. Let me remove this file and copy it again in a minute. I'll say rm, then cus.csv will be deleted. And now let me make the changes. If you see, there is a space in between. And since this is a age column and it is an integer column, if we keep a space, it will consider as a string, and this value will be shown as null whenever someone try to read this and enforce a data type. So let me move this again, copy from local, and I have said send this corrected file to HDFS. Now if I want to run a Hive, what I'll do, I'll create a Hive table and we'll see like how it looks. So inside Hive, yeah, it will take a few seconds. Yeah. If I do a command like a show databases, it will show me the database like we have currently default. If you want to create a newer database, like create database raw, and now you do show database, you have a raw database. Now if I want to use a raw database, so I can say use raw. Now I create a table, create external table, meaning that data resides in HDFS. Internal table meaning that data is managed by what we say, this Hive. So I'll say create external table customer. There are 3 columns. ID, we are going to say that it is a string column. Then there's a name, we are going to say it is a string column. Then there's a age, which we are going to say it is a int column. Okay. Since the file is separated by comma, I say row format delimited. This is the syntax of Hive. Fields terminated by comma. So if you don't know Hive, not an issue. But yeah, I just want to show you how HDFS and Hadoop works in place. So let me see, row format delimited field submitted by comma is stored as text file. Since it is a CSV, it is a kind of a text file. And location where this data is located, we'll give this folder. Okay, we'll give this folder. And once I run this, it should create a table if there is no syntax error. Okay, so here it should be create external table. I just I just wrote table. So it should be create external table. Then the three columns ID, name, and age. And we are saying that this is uh, separated by comma since it is a CSV, stored as a text file, and location is this. Now, if I say that show tables, it will show me that there is a customer table available. And if I do select star from customers, then it should go and read that data. Yeah. So you see, I'm able to read these three columns from the customer table. So this is how it works. And it since this resides around the raw database. So, and also if you want to see this in text, you can do a show create table. If say you don't know what is syntax of table, you can say show create table and table name is customer. So it will show you that this is a table that you created. It is stored as a text file and the location is inside this. Okay. This is how we can connect to Hive. Now, if I want to connect to Spark, let me create one more file. Let's say product.csv. So this product.csv is going to have three, let's say a column called as a ID and a column called as a name. Let's say two columns. ID is one and name is, or let me say category and say name. So ID is one, category is cosmetics, and say there is some product called as let us take any of the product, let's say face wash. Then there is another category called as a you know uh, footwear, and let's say the name is shoes. And let's stick to these two columns and see how we can use this. And let me create one folder inside this called as a product. And I'll copy this file product.csv to product. Okay, we'll see if we can leverage this. So if I do HDFS DFS -ls and see if the data is available. Yeah, I can see this data available. Now let us open PySpark as well in this Hadoop cluster. Okay, and let's see. So whenever you open this PySpark, it will give you the Spark context, Spark session. All of this it will be provided by when you run this PySpark. And if I want to read something, I can do is there's a like we have seen spark.read.table. So if I want to read something from uh, like this, let's see if it is able to connect to Hive. Yeah. So if I want to, read from a Hive table, I can do spark.read.table, and it will connect to, and you give the database and table name, it will give you the Hive table it will connect you to the Hive table. So these all settings are done by this DataProc cluster. You don't have to explicitly manage that connect Spark to Hive. All the connection is done, and you see the data that we have stored in Hive. It is available now. So we are able to read using spark.read.table, give db.table name, and it is connected. Now, if I want to, let's say if I can read from read.option, give header as true and dot csv and say I want to read from this folder. So let me see if I'm able to read it. Yeah, so if I'm able to connect to HDFS as well. Okay, so if you see, I created a file in HDFS. I gave the path user product. I said a spark.read.option header to CSV, and we are able to see the data that we just copied in SDFS. So this is how SDFS all in all looks like, and the services how it connects to each other. Like SDFS, we can read this using Spark. You do using Hive, you can create a Hive table. All those default, uh, you know, uh, default services are available. If you want to have additional service, we can have those option clicks like SBase. If I'll click to the SBase. This is how SDFS and Hadoop cluster in DataProc, including Hive, including Spark and Hive, works. So this is all about this session. Thank you.